Wade.
Hey, Carly.
So today we're going to talk about confidence intervals. And confidence intervals are related to polling. So I'm actually going to explain them through an example of a poll. So Wade, I think you have a good one for us.
Yeah, so I pulled up a poll because I'm interested in what is the general population's education in the United States. So how many people are college educated? How many people are only high school educated? What is that distribution right now here in 2021?
Exactly. So Wade basically wants to know what percent of people in the U.S. went to college or have some sort of higher education. And so again, with polling, we have this population. We have our population of, you said U.S. adults, right?
That's what this polling organization polled.
Okay, U.S. adults. And ideally, we'd ask all of them this question, but we know as statisticians that is incredibly difficult. So instead, we are going to take a random sample. And how many people did they sample?
So looking at this, they sampled 808 active voters.
Okay.
So it's not quite all U.S. adults.
Okay, so actually our population, let's see, instead of saying U.S. adults, I'm going to say active voters. And this is really important because a lot of times one way that people can lie with statistics is actually to use the data they got from a poll of active voters and say it applies to all U.S. adults. But we want to make sure that we keep in mind that our sample is only representative of the population it was drawn from. No subgroups or bigger populations or anything like that.
And one reason I chose this poll is it gave me all this information about these kind of statistics. That's a sign of a good poll, that I understand like what's the sample, how many are in the sample. So if you don't see that information, I'd be questionable about any poll.
Exactly. And this poll says that they did a random sample, which is ideal for polling. And that means we can use whatever data we get to calculate statistics and, more importantly, to calculate a confidence interval. So Wade, what did we get for the percentage of active voters in our sample that are college educated?
So the question that they asked in this poll was question 43. What was the last level of education you have completed?
Okay.
And we had 43% of respondents in this poll respond college degree and 15% saying advanced degree. So if I combine those two categories, I get 58% of respondents have completed some college, at least a college degree.
Okay.
First college degree.
58% have a college degree, at least one. So this is what we got in our sample. But we didn't ask all active voters, right? We only asked 808 of them. So my question for you is, how confident are you that this is correct? Because with sampling, there's always this idea of error. We can't eliminate error unless we ask every single person in our population. So a confidence interval can tell us how confident are we that our percent is close to the true population percent. So in order to create a confidence interval, we want to basically make this into a range is the idea that we're going to do. And you can have a confidence interval where you're any percent confident. A really common one that I see all the time is 95%. So I'm going to go ahead and do that. Wade, in computer science, do you guys do 95% confidence intervals?
We often will do 95%. That's popular. I've seen 99%. I've also seen something like 68%.
That's another common one as well. So a 95% confidence interval, sometimes it's abbreviated as CI, is basically just going to be our sample percent. So this 58%, this is what we got in our sample, plus or minus something. And then instead of saying, okay, 58% of active voters in the US have some sort of college degree, I can give an interval and I can say I'm 95% sure that the true sample percent is within this interval. And that's really powerful because this is just this is a point estimate. The probability that this is the exact percentage is actually quite low. The range is going to be a lot better of a statistic to give to people. So this something that we're going to add and subtract from the sample percent is actually called the margin of error. And basically what it is the z-score associated with a 95% confidence interval times something called the standard error. And the standard error basically measures the error in our sample, and it's based on our sample size. So for 95% confidence intervals, since this one comes up all the time, the z-score is basically just the z-score on the normal curve. The central limit theorem says that if we repeatedly take samples of size 808 from this population, the sample percents are going to follow the normal curve. That's the beauty of the central limit theorem. And so the z-score for 95% is basically whatever z-scores, the positive and negative versions, that have 95% of the normal curve in the middle. Because we're essentially saying right here at 0, this is our expected value, and then we're going to give this range instead of just that 58%. So the z-score for 95, we could definitely use Python to do this. And that's what I would do, because that would be the easiest way. And we end up getting 1.96, or a lot of times you'll see it rounded to 2. So to find my 95% confidence interval, I'm just going to take my sample percent plus or minus 2 standard errors, and that's going to give me a range, and then I can say I'm 95% sure that the true population percent lies within that range.
So we have a margin of error that the survey's given us.
Ooh, perfect.
So the margin of error is 3.45%.
3.45%. So my confidence interval is going to be 58 minus that, which is what?
58 minus 3.45 is going to be, I can pull up Python as a calculator.
Awesome.
So that I can say 58% minus 3.85?
3.45.
3.45 is 54.55. 54.55, sorry.
Oops, sorry. There we go, 54.55. 2, and then 58 plus 3.45 is, that should just be 61.45?
61.45, exactly.
And there is our confidence interval. This is a much better this is a much better thing to give to people when asking, okay, what percent of active voters have a college degree? It's definitely better to give the confidence interval instead of that sample percent. And we can say again that we're 95% sure that if we polled all active voters, their true population percent would be within this interval.
So I am pretty certain, based on this survey, if I understand you correctly, that somewhere between 54 and 62% of US active voters, again, just this population, are college educated.
That is exactly correct.